In this experiment, we're going to have a look at the diffraction of light using a very simple series circuit and breadboards. If we look, we have 3 LEDs in series, a white, a red, a blue, and we've got a resistor in series to prevent the LEDs from burning out. When I connect my circuit, we can see the 3 LEDs lighting up. But if we use diffraction gratings and our phone, we can see what happens when we pass light through a diffraction grating. If I take a 100 lines per millimetre diffraction grating and hold it over the 3 LEDs, what we can see is that the white light is split into visible spectrums on either side of the zero order. If we look at the red and the blue LEDs, they are also diffracted, but they remain red and blue. It becomes more obvious when we use the 300 lines per millimetre how the diffraction grating is actually affecting the separation of these. We can see here that the red has a greater angle of separation than the blue light. And again, if we do it with the 600 lines per millimetre, again placing it over the lens of our camera, we can see that the red is much further away than the blue. The use of the phone and the diffraction grating allows students to actually take a photograph and record their answers and physically see that the angle of separation for the red is greater than the blue. The reason that the red is greater than the blue is because of the formula n lambda equals d sine theta. Red has a longer wavelength, and therefore as lambda increases, so does theta. Blue has a shorter wavelength, and therefore as lambda decreases, so does theta. Hence blue is closer to the zero order than red.